Today we're going to take what we learned yesterday and turn it into story problems. Uh, Good news, bad news. These story problems, there are pretty much, if you look at your first few pages, there are going to be 4 formulas you're going to use. Those are the 4 formulas that you'll use every time. You'll just have to figure out what situation to use them in. Okay. Some of these we already talked about, correct? Like that one we did with the compound interest. We did continuous interest is when you're using p times e to the rt, right? We're going to introduce 2 new ones to you that are actually very prevalent in the science fields. One is doubling time. How long does it take for something to double? Okay. So all you do, you have an initial. Doubling means you times it by 2, and then it's time divided by the doubling time. Okay, how many days will it take to double? This would be if I ate McDonald's every day, how long would it take me to double my size? We should do that, actually. That'd be fun. All right. The one that's more used is half-life. Your initial times a half to the t over d, which is amount of time half-life. Anyone who's in chemistry right now, you're going to be using that one a lot. Also, if you take anatomy or you do anything with biostats, when you take a drug, like if you have caffeine in your system, does caffeine just leave your system all at once? No, it has a half-life. Okay, so after 6 hours, like if I drink that cup of coffee, that's probably 120 milligrams caffeine. In 6 hours, I will have around 60 milligrams caffeine. And in 6 more hours, I'll have about 30, because it never completely gets eliminated. It just keeps getting cut in half, because it's a random, the way the enzymes and such work in your body to break down, it's kind of random when it hooks up to it. So the more there is, the faster it breaks down. So, yeah, half-lives. All right, let's get to it. Let's get to it. All right. The average half-life of glyphosate, I feel like that's missing letters, actually. It's bothering me. It's glyphosate. All right, is 47 days. Oh, never mind. Do you know what this is? Do you guys know what that is? That's Roundup. Never mind. I was thinking a different chemical. That's Roundup. So it stays in the soil for about 47 days, or half-life is 47 days. Never entirely leaves. So if you throw in 450 milligrams a cubic foot, in that many days, let's make an equation for that. All right. So we're going to use A. I didn't listen to this video. I'm going to pretend like A means amount, and that'll help me use A. A is amount. So we always start, this is a half-life one. So my half-life formula is A equals P times 1/2 to the T over D, where D is your half-life. Okay. So what's my initial? How much am I putting in? What am I starting with? 450. That's what I'm actually putting into it. Okay. Because it says half-life, great game when I was in college, that's going to be a half. And that also makes sense. It's not going to go up. The amount in the soil is not going to go up unless you put it in there. The half-life is 47 days. That's my D. And then the T goes on top. So that's my equation. Which makes sense because at 47 days, how many times am I going to multiply it by a half? 1. So if I plug in 47 up here, I get a 1, right? And I'd expect in 94 days that to be a 2 because it's going to be cut in half twice. Okay? All right. So how long until we only have 50 milligrams left in the soil? So where do I put 50? Is 50 a time or an amount? It's an amount. That's the biggest thing we got to learn is where are we putting the numbers? Are we saying equal to or plugging it in? 50 is an amount. So I'm going to do 50 equals 450. We did problems like this earlier where we just plugged in numbers, right? So this is where it's different. We're going to actually need to solve that. Now, I'm going to show you how to solve this with logs. Someday, if you ever take like an AP pre-calc or another pre-calc, I would actually show you how to do this with graphing as well. What do I need to do first? You need to ISO the exponent, right? ISO that. So we're going to ISO. We're going to divide by 450. Okay. Now be careful. If you're doing this with decimals, how many decimal points do you have to use with these? 6. You have to use 6. You could use 6 or 7. So this side becomes 1/9, or if you're using decimals, it'd be 0.111111. Okay. Both should work. I'm going to use 1/9 because I like fractions. All right. Is it ISO'd? Do I have the half-life by itself? Or not the half-life, the exponent. Copy this, make sure I do my work right. All right. What do I do to both sides to get rid of the exponent? I don't want an exponent anymore. What's the magic thing I can do? Natural log both sides, right? Because I get natural log of 1/9. What does this do when I log it? You cut it down, right? Comes out in front. Yarnar. So again, that looks wild. But what are both these? These are both just numbers, right? If you don't like dealing with logs, what could you convert those to so you don't have to see logs anymore? Decimals. I'm going to leave them as logs because I don't want to round. I make a lot of rounding mistakes in my life. So now, you could even think about it like this, right? You have t times that over 47. How do I get rid of the 47 now if I'm solving this algebraically? You times both sides by 47, right? And then how would I get rid of the natural log of 1/2? Should use a different color. Why is this marker broken? Very interesting. I would divide both sides. Oh, it's really broken. I would divide both sides by natural log of 1/2, right? If you guys have your calculators handy, try this. You got to be able to plug stuff like this in. It's going to be gnarly. That's an exact answer. That's the exact answer. The approximate, when you plug this piece in, should be about 148.99 days. Okay, but go and give it a try. I should have expanded it out more for you guys. I just clumped that all together. The next one I'll do more expanded. Yeah, you're good. You're good. Watch your logs. Try it out. I'm going to pause this to give you guys a second. That's good. All right. So that's how you do a half-life one. Every problem we do today is going to have the same exact steps. The only difference is going to be the setup. Looking at this from afar, that looks really messy. I'll do better this next one. Sound good? I'll do better. That's not my best work. That is not my best work. All right, example 3. All right, so a certain battery, chimney crickets, a bacteria doubles in size every hour and a half, 1.5 hours. Create an equation for the amount of bacteria in a dish if you start with 1,000 bacteria using T for number of hours. This is really bacteria because when they split, they all do it almost at the same time, so it is a doubling time actually for how often they split. All right, so let's make our let's start by making our equation. Amount equals, how many are we starting with? 1,000, right? Now it's doubling. So to double, it means we multiply it by 2. I'm going to put 1.5 down here because at 1.5 hours, it should double. So that's my doubling time equation. Okay. Don't be afraid to use your charts. Remember, it is going to be open notes on the test, so don't be afraid to make sure you have these equations written down somewhere. You know how to use them, right? All right. Any questions how I came up with that equation? All right. We're almost done. I should have written that equation somewhere else. Next question is, how many bacteria will be in the dish after 3 hours? Is that a time or an amount? That's a time. So I plug it into T. So my amount is going to be 1,000 times 2 to the 3 over 1.5. Okay. Now, some of you might look at that and say 3 over 1.5 would be 2. So it'd be 4,000, could be 1,000 times 4. If you don't, make sure, again, if you're calculating, when you plug this in your calculator, if you are doing it that way, you would do 1,000, 2, caret key, and then make sure the 3 divided by 1.5 is in parentheses. Because if you do not put that in parentheses, it's going to do 2 to the third power and then get an answer and then divide the whole thing by 1.5. So make sure, try it in your calculator. Make sure you guys can use a calculator. That's going to be a big deal for this one. I know I keep saying it. Because you should get 4,000 bacteria. Now, if you see a question like this on a test, or if you're taking like AP Bio someday, or you're taking like AP Chem or Chem or Bio, you should realize that 3 hours is 2 doubling times, so you just double it twice. You're not going to be able to do it for the next one, though. All right, how many bacteria will be in the dish after 5 hours? Again, is that a time or an amount? That's a time. So my amount of bacteria would be 1,000 times 2 to the 5 over 1.5. All right, you could also do the 5 divided by 1.5 first and get your decimal for it. But then you're rounding. I really want to avoid rounding. When I plug that in, I get approximately 10,079.37 bacteria. One freshman. And that's why we get sick, right? Any questions on those two? All right. How long until we have 1 million bacteria in the dish? So is that an amount or a time? That's an amount, and we're looking for how long. So this one's gonna be a little bit more intense. So the amount is 1 million. Like how much debt I have. No, that's too much. So I'm looking for T, and then I'm keeping my original equation the same. All right. All right. What's my first step going to be on this one? Should I go and log it right now? Is it ready to be logged? Gotta divide. Yep. Thank you, Siri. I'm going to divide both sides by 1,000. Right? You need to get that exponent by itself. 1, 2, 3. So I get 1,000 equals 2 to the T over 1.5. Now, there's 2 ways I can solve this from here. I don't know. Do you guys like the change to base formula? I'm going to show you, how about this? I'm going to show you the way I don't do it this one time, And this way works every time. If you like it, write down, use it this way. It's not the way I do it. It's not the wrong way. There's nothing wrong with it. It just takes memorizing an extra formula. So you could, again, just treat this like a bonus way to do it. I want to show it to you guys one time. I could log base 2 both sides, right? Is log base 2 on your calculator? No, it's not. But what happens when I log base 2 this, these would cancel. I get t over 15 equals log base 2 of 1,000. Okay? And then from here, I would do my change of base formula, which is natural log of 1,000 divided by natural log of 2, and then times by 15. This way always works as well. That's just not the way I do it. Oh, 1.5. You're right. My bad. Thank you. Very observant. All right. So that way will work. I'm 100% okay with it. I just always stick to using natural log on both sides. That'll work in any exponential, anytime. So what I'm going to do now is I'm going to natural log both sides. I'm really going to try to show my steps this time. I'm not going to do any quick canceling or anything, okay? I'm going to try to go step by step. Now, when I natural log, what does it say I get to do with that exponent? I get to move it in front. Okay? Okay. Now, remember, with multiplication, you don't need it. I'll just leave it. I'll leave it. All right. Now, how do I get rid of that 1.5 on the bottom? You would multiply both sides by 1.5. Right? So I get 1.5 natural log of 1,000 equals t times natural log of 2. Getting rid of that 1.5. Now that natural log of 2 is a number. How do I get rid of it? Oh, that's what I should do. I would divide by natural log of 2. Okay? Because then those will cancel. And I get t will equal 1.5 natural log of 1,000 over natural log of 2. Okay? I know this looks wild. I do. Like if you walked in last year and you saw this on the board, you'd be like, what is going on? The biggest thing I can tell you is if you saw 3 times t over 2 equals 5, could you guys do that problem? Would that look scary? No. These are the exact same. These two equations are the exact same thing, right? You would multiply by that number underneath and then divide by the 3, okay? I know logs look really, really scary, but this is the same thing as this. It's just extra writing. Hardest part is plugging in your calculator then. I got 14.95 hours. Right? Guys, this actually, so with bacteria, if you start with 1,000 bacteria, by the middle of the day, you could have 1,000,000. Isn't that crazy? You guys remember, I don't know who I had. Did you guys ever grow bacteria on a dish at some point through your high school career? And it becomes visible, right? Think about this. It starts with 1 or 2 bacteria, and then it's visible within 2 days because there's millions on top of each other. Bacteria is wild like that. That's why be careful. Never mind. I'll save that joke for later. All right. Holy smokes. All right, let's do more logs, man. All right. Here's what I want to do this time. This population is decaying continually. A continuous means we're using PERT. We're going to use PERT, P times E to the RT. Here's what I want you guys to do. I want you guys to try something. Pause it if you're on the video. All right, let's compare and contrast. Do y'all agree this is my P? My initial, my principal. So it's 45,600. Then E. Now, biggest mistake. It's 0.8%. What's 0.8% as a decimal? Yep, you got to move it twice. Got to move it twice. Negative 0.008 T. Why is it negative? It's going down. R is negative if it's going down. All right. That's good. This one came up in one of the earlier homeworks too. All right. Oh, let's go back. I got to read the question again. It's my first day. This is what? Years since 1995. We got to keep that in our head. Since 1990. What were you guys doing in 1995? I was watching Teenage Mutant Ninja Turtles and playing my NES. Living my best life. All right. What will the population be in 2035? Is that a time or an amount? Time. So where do I plug that in? In my T. What do I plug in? 2035? How many years after 1995 is 2035? 40, right? 40. So what will that population be like in that city? This is very similar to the city we live in, actually, for population growth. Yep. I got approximately 33,112.40 people. Okay. Because it's approximately, so read your situations, okay? Sometimes they say round to the nearest person because that's what a lot of times you do with people. For estimates and statistics, you can use decimals. Oh, I'm going to leave that equation there. That's perfect. In what year will the population reach 40,000? Is 40,000 an amount or a time? Amount. So I'm setting this equal to 40,000. All right, setting that equal to 40,000. All right. Pause the video if you want. One. All right. Again, if I treat this, this is 45,600 times something, right? How do I get rid of timesing something? Divide it. Divide it. Right? I got to go over here. I'm going to run out of room. So I get e to the negative 0.008t equals. All right, so you have options here. Some of y'all change that to a decimal, 6 decimal points. Some of you guys didn't. I'm going to leave it as a fraction. Do you notice this? These are both zeros, right? You could cancel those if you want to make your life easier. But I'm going to leave it as a fraction because I don't feel like writing the decimals, although this is just as much work. Right? So far, everything we've done, you guys did a long, long time ago. We divided. New step. New step. We have an e, right? How do I get rid of e's? What do I do to both sides? Natural log. So if I natural log this, these cancel, and I get negative 0.008t equals natural log of whatever this is. All right? Right? Stop me where questions on that. How do I get rid of anytime I see an e to the power? Natural log it. This one I don't have to do anything with logs on both sides, and it just cancels. So now what do I do to both sides to get rid of that negative 0.008? That's just times, right? What's the opposite of timesing? Dividing. So I get t equals, that's just a mess to plug in. What did you guys get approximately if you rounded? Should be, I like it, 16.38. Ben Miller didn't mention that in his article. All right. Now think about this. What does that mean in the context of this problem? Years after 1995. Be careful if they ask what year is that, what year would that be? 2011? All right. Oh, did I ever start recording again? I did. There's much rejoicing. All right. 1 year later. All right. Get out of here. All right. Now, I'm going to teach you guys a shortcut. This is actually a pretty good shortcut. Anytime you get a question about how long until something gets halved, do I have to use the initial amount? No. Because to cut something in half, if I have a rate, it'll be the same amount of time whether or not I start with 1,000,000 or 5, right? So whenever you get a question, how long until something gets halved, what I do is I take, what was my rate? My rate was negative 0.008t. That was my equation, right? My initial was 45,000 ... right? What if I start with one person? Would the amount of time it takes to go from 1 to a half be the same amount of time as it takes 45,600 to get to 22,000? Yeah. So anytime you see a halved question, you're just make your initial 1. And then what's this equal to? A half. Anytime it asks how long to take doubled, start with 1 and you end with 2. Well, if I say tripled, start with 1 and end with 3. I don't need that screen right now. So the question was how long until this gets halved? All right. If I start with 1, what's my first step here? What can I do first step? Is there anything in front of my e? No. Because it doesn't matter what we start with. It's just how long till it gets cut in half. If you start with, it's the same as if I start with 10,000. If I start with 10,000 and set it equal 5,000, my first step is to divide, and it's a half anyways. So anytime it's a halved, doubled, or tripled, start with 1 and just set equal to half, double, or triple. It'll work every single time. Because then I get to skip the first step. What's going to be my first step? Just, how did I get rid of an e? Natural log. Natural log. Do these cancel? Yeah. Boom. No, this stuff, I will say, this does take a lot of practice to get pretty good at logs. Oh, I got an idea. What do I do to both sides to get rid of that negative 0.008? Divide. There you go. Plug that beast in your calculator. It just looks wild. like my kids. I got, what's that, 86.64 years after 1995. Uh-oh. Uh-oh. Hey, my song's still playing. Good, we have time for one more. Wait, did I ever unpause it? I did. Wait, what? I never paused it. All right, let's do one more. Oh! Yeah, we'll do this one. All right, so this problem is a little bit beyond what we need to do. This would be what you see in pre-calc. We're going to skip this part. I'm going to skip that part. And I'm going to give you the half-life is 60.27. This is not the right way to do it, but it is a way to do it. The only reason I'm skipping that part is I want to show you one half-life equation. But if you are taking pre-calc next semester, you will see these exact same problems, just like one step more. So it's pretty much 65% review for the college pre-calc. So that is a half-life. All right. So if that's my half-life, what's my equation for iodine 125? So if I'm drinking iodine, don't do that. You will perish. If you injected 60 milligrams into your body, so 60 is my starting, right? 60 is my starting. For half-life, what do I put next to it? It's not continuous. It's not a doubling. It's a half, right? And then it's my T over 60.27. This is not going to be accurate because I rounded the half-life how many decimal points? 2. So that's a rounding. So it's not going to be highly accurate, but it will be something. Questions how I got this equation. Initial amount, half-life, you put in your half-life under T. Okay, that equation's earlier in the packet. Now this question says, how much would be left in 50 days? Is that an amount or a time? Amount or a time? What do you guys think? That's a time. So do I put in for T or A? T. 50. 50 over 60.21. That 60 milligrams is actually a decent amount. That's a lot to put in your body. And I plug that. What do I do with that then? Is there any solving to do, or do I just plug and chug? It's plug-in time. I got, yep, 33.76 milligrams. I did my calculations with this to find it. So what you do is you make this a PERT equation, and then you solve for how long it'll take to be a half, and that's half-life. You don't have to do that. I'm just telling you what the half-life is. It's a magical, here's half-life. This is actually perfect. We're going to skip the next one. That's good. Does this answer make sense? Is 33 pretty close to a half? Yeah, because it's 50 pretty close to 60. So it makes sense that you're almost to the halfway point. All right? That's actually, just so you guys know, we will be skipping example 5. I'm not going to make you guys do the bluegill problem. That is for future. And then that's perfect. We're going to do money and regression on Monday, and then we're done.